Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about the difference between microprocessor and microcontrollers. So microprocessor, it consists of only central processing unit. So no RAM or ROM or IO ports or timer or interrupts will be available. So it is just a processor, it is a standalone processor. On other hand, if you go with a microcontroller, it consists of a central processing unit, that is a CPU, a RAM, a ROM, IO ports, timer, and interrupts. Everything available in a single chip. So whenever you are using an application, so these are the essential things that will be available on a single chip itself. But if you go with a microprocessor, we need to buy external RAM, ROM, IO ports, and timers and interrupts. We need to interface that also. Second one, so designer can decide amount of RAM, ROM and IO ports in microprocessor, but in microcontroller the fixed amount of on-chip ROM and on-chip RAM and similarly limited number of IO ports, limited number of timers, again interrupt sources will be available. If the designer needs more than this, they can interface externally. If it is sufficient, they can use internal RAM, ROM or IO ports. And microprocessor based system design will be very expensive because we need to have a hardware complexity, because we need to take a chip, RAM, ROM and IO ports and timers, and that should be interconnected with the microprocessor. So if we want to connect with the microprocessor, so we need to connect the address bus, data bus and control bus from a microprocessor to that corresponding chip. So if you are interfacing a RAM or ROM, whatever you are interfacing, we need to connect all the address lines, data lines and control lines from a microprocessor to that RAM ICs. So what happens, it makes a very complex, so it will be expensive. So we need to have an PCB board and we need to connect all the things, and then it makes a expensive one. Again, if you go with a microcontroller, the cost is less, because if you need to buy only a single chip, so inside the single chip itself, it have the RAM, ROM, IO ports and timer. No need to externally we need to interface. So totally the cost is less. Again, microprocessor we can take it as an adaptability, because it have a higher end of processor. Again, everything we have externally interfacing. So amount of RAM, ROM size, everything we can choose it. But in microcontroller, it have already fixed amount of this. So if we want go higher, we can go with this amount of external RAM or ROM depending upon the applications. So microprocessor, it is a general purpose applications, but if you go with a microcontroller, it's a single purpose. That means if you design a system microprocessor, it will be general purpose system that can be used for any application. For example, if I design one system, if I want to change that system from this application to some other application, it is possible in a microprocessor. But microcontroller, normally it will be meant for single purpose. For example, if you take a washing machine, it can perform only the washing cloth. So the single purpose that only selected for a microcontroller, it can perform only that particular tasks. No other task will be able to do it. But if you have a microprocessor, it have a higher end of evolutions. Microcontroller have a limited evolutions only, but still if you go with an application of, if you go with a product, the microcontroller will be best one. Look at this, the comparison for the microprocessor and microcontroller. This is the microprocessor based system. Look at this. Actually, the CPU, that is a processor, only the microprocessor. No other things will be available. What we do, so we need to interface all the things externally. Look at this, RAM interfaced, ROM interfaced, and IO ports, timer, serial ports, everything that will be connected externally to the microprocessor chip. Look at this. This is the data bus. We use a bidirectional data bus. So normally it will be 8-bit bidirectional data bus will be connected, because we need to transfer the data from microprocessor to RAM and RAM to microprocessor. Similarly, for all the devices, ROM, IO ports, timer, serial ports, we need to transfer the data from the IO devices to microprocessor. That's why this data bus is connected. Look at this address bus. So normally address bus will be a 16-bit. So these address bus will be connected from this microprocessor to all the devices, because we need to choose the addresses. So even it will be IO ports, we need to choose the different addresses. Similarly, if we go with a RAM, it contains so many locations. So each location will be separated by using this address bus. So depending upon that address buses, the number size of RAM and ROM will be varies. For example, if you connect with a 16-bit, 2 power 16 memory locations can be addressed. So 2 power 16 is a 65, 536. So more than that, if you need to interface, it means we need to go with higher things. So examples are, look at this for a microprocessor. There is an Intel 8086 microprocessor, Motorola 680XL, all versions. That is a sum of the examples for the microprocessor. So internally, no memories or IO ports timer will be available. Everything we need to interface with externally. Look at this microcontroller based system. So microcontroller, I already told you, it have an on-chip RAM, ROM, everything. Look at this. This is the actual chip. So inside this chip, CPU, RAM, ROM, IO ports, timer, serial ports, everything available inside this port itself. So what happens, once if you buy this single chip, it can be useful for applying it an application. No need to interface externally RAM or ROM because it is already available internally. So some of the examples for Motorola 6811, Intel 8085, Zilog Z8, PIC microcontrollers, that is a 16X series. This is the some of the examples for the microcontrollers. Thank you.